Welcome in everybody to another lesson. Today we are going to talk about triangles and types of triangles. So when we think of a triangle, of course, it is a three-sided polygon. Well, what is a polygon? A polygon can have any number of sides, but it is a closed figure that has straight edges, that has straight lines for its edges. It can't be curved. A polygon could be a triangle, it could be a quadrilateral, which a quadrilateral means four sides, something like a square. It can be a pentagon, which would have five sides. It could go up to infinite number of sides. But today we're going to focus on triangles, which are the three-sided polygons. So we have several examples of triangles here that are just based on their sides. We'll talk about their angles in a minute. But if you base it just on the length of the sides, you have the first example, which is a scalene triangle. A scalene triangle means all three sides of a triangle have different lengths. How you can remember that is they're all different, so they're all scared of each other. Scared, scalene. Try to pair it with that. So you got 5 inches, 7 inches, 10 inches. They're all three different lengths. So it's a scalene triangle. Remember, scalene, they're all different. They're all scared of each other. That's a good way to remember it. We jump over, we have another type of triangle called an isosceles triangle, which means at least two sides of the triangle have the same length. An example here, we have a triangle with one side 5 inches, the next side 5 inches, and the third side 7 inches. That's just an example. So two of the sides are equal to each other in terms of length. That makes it an isosceles triangle. Then for the third type, we have an equilateral triangle, which means all three sides have the same length. How you can remember equilateral is equa, like equal. Lateral means side. So literally means equal sides. That's literally what equilateral means. So you'll have, in this example, 3 inches, 3 inches, and 3 inches. They're all three equal. So that's how you would classify triangles based on their sides. Now, we can talk about also dealing with triangles here. We could talk about their angles. It is important to know that in a triangle, I'm just drawing a triangle, we have angle 1, angle 2, and angle 3. Angle 1, angle 2, angle 3. In a triangle, the sum of the measures of the three angles, they will always add up to 180 degrees. So the sum of the three angles of a triangle will always equal 180 degrees. It won't equal anything else. If it equals anything else, you don't have a triangle. It's that simple. So let's see here. Let's leave that formula up. I did not mean to erase that. So let's say we know the first two sides, right? Let's say we have an angle 75. The other one is 60. We don't know the measure of the third angle. So the measure of angle 1 was 75 degrees. The measure of angle 2 is 60 degrees. But we don't know the measure of angle 3. No problem. We know that they're going to equal 180 because it's a triangle. What we should first do is add up 75 and 60. You'll get 135. So you'll have 135 degrees plus the measure of angle 3 is equal to 180 degrees. Well, since you don't know the measure of angle 3, that's your unknown. You treat it like a variable. And of course, with variables, you want to isolate that term by itself. So in this case, we need to subtract 135 from both sides. You subtract 135 from the left side, you just get the measure of angle 3 is equal to 180 degrees minus 135 degrees. So the measure of angle 3 is equal to, what is 180 minus 135? That would be 45. So the measure of the third angle is going to be 45 degrees. You can always check your work by sticking it back into the original equation, and if you did, you would find 75 plus 60 plus 45 do in fact equal 180. So that's how that works. Alright, we'll do another example here. We'll solve for a missing angle. Let's say, well, let's see here. We got angle 2. Angle 1 equals 61 degrees. Angle 3 also equals 61 degrees, but we don't know the measure of angle 2. Well, we know angle 1, that's 61 degrees. We don't know the measure of angle 2, but we do know angle 3 is 61 degrees. We know the sum of these three angles, that has to equal 180 degrees. Alright, so of course, on the left side, you want to add up 61 and 61, which should give you 122. Plus the measure of angle 2, because we're trying to solve for angle 2, that would equal, well, 180 degrees. Whoops, I forgot the degree symbol. It's always important to have your units. Largely in the world, angles in general are measured in degrees. When you get into trigonometry, there is another way to measure angles, but that's for way down the road. Right now, we're just going to focus on them being in degrees. So, of course, we have 122 plus the measure of angle 2 equals 180. Well, we don't know measure of angle 2. We'll treat that like a variable. So, in order to get the variable by itself, you got to subtract 122 degrees from both sides. When you do that, you'll have the measure of angle 2 is equal to 180 degrees minus 122 degrees. Now we just do a simple subtraction problem. 180 minus 122, well, that's just going to equal 58 degrees. So that missing angle, the measure of angle 2, that's equal to 58 degrees. And you could do it with more examples, but that's how you solve for a missing angle of a triangle. You just add up the two angles you have plus your missing angle, and then you'll isolate the missing angle by itself like a variable, subtract the sum of the angles that you have so far from 180, and you'll get your missing angle. We could do one more, though. We'll do one more for good measure. I'll throw that in for one more. Alright. Let's say here we don't know angle 1 this time, but angles 2 and 3 both equal 45. Angles 2 and 3 both equal 45. So we don't know the measure of angle 1, but we know the measure of angle 2 is 45 degrees. And the measure of angle 3, that's also 45 degrees. We know that the sum of these three angles is going to equal 180 degrees because that's a triangle, 180 degrees. So, of course, measure of angle 1, we'll treat that like a variable since we don't know what that is. You'll still have the measure of angle 1, but you'll want to add up 45 and 45. You'll get 90. You'll have 90 degrees. Which that would be all equal to 180 degrees. Now, of course, you want to get the measure of angle 1 by itself since that's the variable. So you'll have the measure of angle 1. If you subtract 90 from the left side, you just have the measure of angle 1 by itself. That's equal to 180 degrees minus 90 degrees. So the measure of angle 1 is equal to, what is 180 minus 90? That's 90 degrees. So the measure of angle 1 would be equal to 90 degrees. So that's how you solve for missing angles of a triangle. Now, we've talked about the sum of triangles. The sum of the interior angles of all three inside angles of a triangle is 180 degrees. We can also classify triangles by their angles. So let's say we have three acute angles here, right? We have three acute angles. Well, that is an acute triangle. It turns out that in any polygon, the number of sides of the polygon you have, that's the same number of angles that you have, of interior angles that you have inside that polygon. In an acute triangle, all three angles are acute. This could have been 51, 59, and some other acute angle. So you could have had that also. Or you could have, which I think would have been 70 for the third angle. But basically, in an acute triangle, all three angles are acute. All three of them are. Then we have a right triangle. We have a right triangle here. That little corner piece I drew, that means that's 90 degrees. That denotes a right triangle. So we'll say one angle's 30, one angle's 60. Right? In a right triangle, you can only have at most one right angle. And that makes sense, because if you add up, if you had two right angles, you would already be at 180. The third angle would end up putting you over 180, which would not make it a triangle if you had more than 180 degrees. So in a right triangle, you can only have one right angle. And as we're about to find out here with an obtuse triangle, we'll say one angle's 120, one angle's 30, another angle's 30. We have an obtuse triangle. In an obtuse triangle, you can have at most one obtuse angle. Because if you had two obtuse angles, you would already be over 180, which would violate a triangle. That would violate the sum of the measures of the angles of a triangle. So you have acute, which means all three angles are acute angles. A right triangle, which means you have only one right angle. An obtuse triangle, which means you have only one obtuse angle. So that's how you classify triangles, based on angle. Now, we can classify both based on length and on we classify based on length and angles. So this acute triangle also happens to be an equilateral because all three sides have the same length. So this particular triangle is acute and equilateral. You can have an acute and equilateral triangle. You can have acute and scalene and acute and isosceles also. That works. A right triangle, let's say this side is, we'll say 1. Yeah, we'll just make up some, we'll say we just have a right triangle. I don't want to teach you wrong because Whenever you have a 30, 60, 90 triangle and a 45, 45, 90 triangle, there are special qualities about them. Let's just go with a general right triangle. Let's say you have 3, 4, and 5 for your lengths. Of course, the left side here in the bottom, those are the legs of your right triangle. This slanted piece here where it has a measurement of 5, that's called the hypotenuse, which we will get more into right triangles 2 lessons from now. We have a special section on right triangles coming up. But this one would be right and scalene because all the sides have different lengths. You can have right and isosceles. You can't have right and equilateral. It doesn't work. You can only have right and isosceles as the only others. You can have acute and equilateral, acute and isosceles, acute and scalene. But when it comes to right triangles, you can have right and scalene or right and isosceles. You'll never have a right and equilateral triangle. Now, let's say we have 5 here, we have 5 here, and we have 10 here. You can, in theory, have an obtuse and isosceles triangle. That does work. You can have an obtuse and isosceles triangle because 2 of the sides are equal to each other. But you see, you can also have an obtuse and scalene triangle, but you can never have an obtuse and equilateral triangle. That never works. So those are just some things to note about naming triangles here. So the next lesson is going to be about square roots. We're going to take the square root of numbers because it's leading into something even bigger after that. So I hope everybody has a good day and take care.